Thank you very much. Yeah, so thanks for stopping by today. Yeah, so firstly, apologies for this being in English. It is unfortunately the best I can do. But yeah, so I'm Michael, so I run a kind of infrastructure and cloud ops team at DataCamp. So we're going to first look into a bit of a use case as to how we use Docker. And we're kind of going to go into actually why this is relevant to me talking about serverless. And we're going to go kind of back into kind of like how this actually applies to everyone else. A bit of a security detour, because it's kind of a fun topic. You'll see why once I tell you about what we do. And then back to the application of like how this is actually relevant for people using it or going forward trying to use it. So what DataCamp are, so this won't be a sales pitch, it's just useful to know. But yeah, so we're an e-learning platform. So we allow you to learn languages online. These can be languages from Python, R, they can be getting started type courses, right the way through to maybe a TensorFlow Keras course, learning how to build a convoluted neural network. So we do a kind of full range of like data science related courses. We follow this kind of methodology of like learn, practice, and apply. So the learning stage is ultimately the easy bit. So this is where we kind of give you videos, we show you the content, we talk you through the content. This is what you can do for free all across the internet. This is the super easy bit. This is just about curating content, making sure we produce the right content for what people want, and then presenting it to you. And like, as you watch it, as you listen to it, you hear about all the concepts. But we then have to take you into the next stage of that learning cycle. And like, it's not just about hearing something, it's about being able to do it yourself. This is where we get into the fun side. So this is how we do the kind of practice apply stage. So this is kind of our next stage. And what you'll see actually on the right-hand side is an IDE. Now for Python, R, whatever language it is, we present this same kind of environment. We present you this concept of you can type some code into your browser. So whatever you've just learned, whatever you just watched a video on, actually you can continue forwards, and you can then do this directly in the browser, and we'll help you kind of walk through functions, how to use them, how to actually get by. Where this becomes particularly complex and interested is whatever code you type into that top section, we actually go behind the scenes and run. So if there's a Python course, if it's an R course, we're going to take your code, we're going to take it to one of our servers, we're going to execute it, and we're going to send a response back to you. And that's where it gets a little bit more complicated. Why is this serverless? So this is actually like a second stage of structure on serverless, in that like we're used to the concept of serverless being a developer deploys a block of code, they deploy it, not worrying about where it's getting deployed to. Some event triggers, the code runs, they get a result back. What this is actually doing is deploying a serverless system into the user's hands. So a user comes to the site, they can type out their code, they can figure out what they're going to execute or run, and then it runs. So as far as like our end users are concerned, this is a serverless environment. And like that's kind of what we're going to be talking about. And it's also interesting to see how some of the issues with this kind of environment actually relate back to some of the issues you can have in a normal serverless environment. So just to look at this in a bit more detail, so kind of top right, you can enter code, on the left instructions, and down here is the output. So like you'll see top left of the output, it says IPython shell. That's like exactly what we're doing behind the scenes. So as you type this code and you hit run or submit, we take this off behind the scenes. We have a container running Python. We literally just pipe your code directly to the input of that container, execute it, and send you the output back. So down here, you can see the output of this kind of 7 add 10. Equally, down here, you can just type Python code. So this is all about just executing code as seamlessly as possible. And then like the later stage of learning is actually we do parsing of kind of the response and how you've got to that response to figure out whether it's the correct response or not. How we go by this is actually like anything you type down here, and the reason why we do this is like if the challenge is print 7 plus 10, the answer is 17. But any developer will know kind of there's a lot of ways to get to the answer 17. Like 7 plus 10 is easy, but maybe you do 6 plus 11. And like trying to figure out whether these solutions are right is really complicated. If we force users into saying a print 7 add 10 is the only way to solve this problem, they're not going to come back because there are dozens of different ways to solve every problem in this space. So what we are getting towards is like there is many, many solutions to get to the same right answer. So that's what we want to be able to parse for. Just to come away from what we do for a second, so serverless can sometimes originally sound like a scary concept. It's like moving away from what you know, it's no longer deploying onto servers you own, it's not even necessarily the kind of microservice Dockerization you may have already done. But actually, it's not as alien as it sounds. So a good example of this is kind of CI solutions. Now, CI doesn't immediately appear as serverless, often because you're actually running a CI server. But actually, how you build it, how you model it, in your GitHub repo, in your whatever repo, maybe you'll just kind of have this little snippet of run code. What's actually happening here is you are defining a snippet of code that at some point, maybe on push, maybe on a commit, will go to some backend system. It will execute. In this case, we're talking about a Docker build. And then the response will be returned, which might be a Docker image. It might be some testing framework that you want to run on build. There could be all sorts you're doing here. So actually, this isn't so alien. Now, there's various logos up here, like maybe Jenkins, Drone, CircleCI, GitLab. All these have this kind of same concept of you put a little YAML file in your repo with a snippet of code that can run, it can go and do stuff, and then you can come back to it later and see what happened. So this is already the workings of serverless. And as we look more and more to the internet, so bottom left, we can see the Go playground. What we see here is actually like, we've gone through the stages of things like JS Fiddle. Like, they're a super simple concept because it runs back in the user's browser, so there's no worries about a backend server or compromise of a backend server. But as we get to the Go playground, it's server-side code. It needs to go, it needs to be compiled, it needs to be run, and needs to be returned. So it's run in a slightly different way, but it's the same concept of it's sent to some kind of isolation container in the back end and comes back. So this all comes to like what the point of doing this is, and like how you can build a business on serverless and why you might. So I say we've all done Dockerizing. Like, I don't know how this looks around the room, but hopefully by now, like, Docker's been out 5 years, maybe 6. But yeah, like, we should all have got to the point whereby maybe we're moving some of our services to Docker. Maybe we're starting to understand the value of moving stuff to Docker. This can be for all sorts of reasons, like reliability, general good practices around getting towards more stateless services. Prior to this, it was pretty common to build big monolithic apps. You expected it to be running for the next 2 years without a restart. You expected it to kind of keep going. You might have had state in memory. Docker just gives us some new best practices, mostly on the basis that we know it can be killed at any time. So like your Docker container might last an hour. It might last a day. It might even last a month. But we get more and more into this concept, particularly as we go towards cloud computing, again, where instances can be killed at any time. Like, they're not as persistent as if it's sat in your data center. Then it gives us a new thinking of like how this actually works. So when we look at kind of the timelines of this, like Docker was originally launched in 2013, went to kind of stable releases in 2014. DataCamp was founded around the same time. So we were working on these kind of serverless technologies around the same time. What actually happens behind the scenes? So this is the simplification of like how you can actually think about this serverless process. So the user comes to the site. This is a simple bit. Now, behind the scenes, we happen to be running Amazon ECS. This is actually completely irrelevant. So we've opted to go cloud native. You could equally go open source. This could be Kubernetes, it could be OpenStack, it could be a random host running Cryo, Mesos, Rocket, whatever you're thinking. Like, this isn't specific to tech here. But we then launch a container. So user comes to our site, they click on a Python course, so we launch a Python container. If they click on an R course, we launch an R container for that course. If they click on TensorFlow, we'll launch a TensorFlow specific container. But then at the end of the day, the user is connected directly to that container. So what we're effectively doing is spinning up this little dedicated resource for that user to use for their session. And this is how it materializes to the user. The user just comes into the IDE, they are launched with a terminal, and this terminal can send commands directly to this backend and just send them through and see what needs to be done. A quick sidetrack into if there weren't containers, if we didn't come across Docker, like there's loads of other solutions around. The catch is they're all a lot different to Docker. So like full VM would have been an option, going kind of KVM route. Now, these are really good for like security isolation, but they're pretty heavy. Like if we had to spin up a new full machine every time a user landed on our site, that would rack up our bill pretty quickly. And it would take ages. Like users aren't going to wait around for a couple of minutes waiting for a machine to boot. As we go down, like emulation, unparsable code, or unparsed code, yeah, like we could regex people's solutions. We could go, did you type print? Did you type 7 and 10? But it's not really a definitive, like, did you actually understand the problem? So by executing it, we can check solutions rather than just input. The issues. So this is where I'm going to go into that bit of a security detour. So this is the fun of running user code on your servers. Yeah, security. So code execution on our server in our backend. This is generally, when we talk to a pen tester, the first state of a compromise. So like, as soon as someone gets code into your backend servers or running in your environment, that's not normally a good sign. And we're using Docker as a security sandbox, which, again, is completely not what it was built for. Like, it's not bad, but yeah, it's a long way away from being super secure. So it's got a lot of controls in place, but it's not what it's built for. It doesn't provide complete system isolation. It doesn't provide complete resource isolation. So using this to protect us from a user is OK, but something that needs a lot of mitigations and mindfulness in place. This is a good example of one of our kind of pen test reports. If you've ever had a pen test and got a CVSS score of 7.5, you generally react immediately and you go like, okay, this is a real problem. Like, we've got remote code execution in our environment. This is generally a bad thing, but in our case, like, this is our core business. And it's something we consciously go, okay, we're not going to fix this, so how can we limit the damage of it? How can we make sure they're not actually going to do any of the side effects of this? Other things to consider are also, when it comes to cloud environments, they're not free wins. So you do have to understand a little bit of behind the scenes how it works. So particularly in, say, Amazon's case, Google's case, you can attach security credentials to a whole instance. Now, this means you might give them write access to some storage or the ability to spin up instances or send messages. How this works in these services is they actually provide a kind of API service that's next to your machine, and you can request it and get credentials back. And this actually means, like, if in any case you're not already doing least privilege, you've granted a few too many permissions while you're trying to get something up and working, yeah, it means actually, because a user is in that environment and can then access through to the things that a box can access, they can hit that metadata service. Down the bottom here, you actually start to see one of our mitigations already. So we're actually doing egress filtering on these boxes. But yeah, this isn't always the case. So this is actually not our site. This is someone else's site doing a similar thing to us and actually returning credentials for Amazon. So yeah, it's something that's very easy to overlook. And while it sounds like this is something that's only relevant because we're putting users in a shell, it can happen in other environments. Like, the chances of a system getting exploited, the chances of someone getting to a remote shell position are hopefully low in most applications, but there's always a possibility. So particularly if you're not running things like least privilege, like getting access to a box and breaking out is suddenly easier than it sounds sometimes in a cloud environment. This is the other excitingness we see. So we often have our pen testers come in and they go, oh, I've got a Python shell. I can do fancy things here. I can get a remote shell out. I can finally get to a bash prompt, and I can run some stuff. We also offer courses in bash, so we can drop you straight in a bash shell. It's much easier. And then what you see here is someone running a crypto miner. This is actually more common than you'd expect. I mean, like, I say than you expect, like, if we launch a public shell, you kind of expect people to do this. But yeah, again, like, this has been stopped in this case, but it's something around, like, if people can do it, if you launch people into a Python shell, a Bash shell, whatever, they're going to try and run stuff. So it's something we've got to be thinking about and understanding how we can manage, how we can work with this. How we go about mitigating some of this. This is where we start to come back to more of the serverless model, more of thinking about general good practices. Docker puts us in a great position whereby we can rapidly redeploy small parts of applications. Serverless is the same, because it's a similar execution model. And actually, like, some of the things we're doing on our current, say, Docker services and Docker hosts are already coming for free in a serverless world. So things like the fact that we have limited execution time on containers. Our user containers will only ever be up for around an hour at most. On the whole, this is plenty of time for a user to come to our site, do an exercise, and move on to the next exercise. Like, they're not going to be sat solidly coding one problem for an hour. They're just not that complicated. Or people give up. But yeah, the simple version is, like, we know those containers don't need to last that long, so we can preemptively kill them. And actually, this applies in most applications. Like, as long as you have good Docker best practices, as long as you have good setups, like you're not keeping state in your containers, as long as you have multiple containers, you should be able to regularly kill these, have no effect on your prod environment, and also have some extra kind of happy mindset that you don't have state building up in a container. You don't have to kind of worry about next time a host gets killed, is your application going to go down? Because you know they're being cycled really regularly. And we apply the same concept to our actual physical hosts. So, like, a host never needs to last. Here we go for 2 days. This is just kind of a natural auto-scaling life cycle of a box. We could go smaller. We could go higher. This is, again, the concept of, like, if someone does break out of a container, does get some more access than they should do, like, no, it's not good. They could affect other users. But it's not that they're going to have guaranteed compute power for the next 2 years. They're going to have a day, they get shut down, and hopefully in that time we've detected it anyway as well. As we continue through, there's lots more topics we can think about. So environment isolation is, again, like, it applies to all concepts of kind of networking, running applications. Like, if two things don't need to talk to each other, don't let them. So in this case, like, we segregate our user environment from our actual main website. As we get into restrictions, like containers, if they only have 100 meg of RAM to work with and a fraction of a CPU, it's a lot easier to see when they're doing the right thing because they're hopefully running at 50 to 80% utilization. If they're doing the wrong thing, they start spiking. Equally, if you get a crypto miner in a box and it doesn't have 8 cores of CPU and 64 gig of RAM, it's going to be a lot slower. Like, it's really not going to be useful to someone. And yet, generally locking down environments. And monitoring. Like, monitoring is key to everything. We all know this. If you saw the kind of Elastic Stack demo next door, again, like, it's a great example of process monitoring, network monitoring, application monitoring, all come together to give you really good insight into your system. And yeah, like, this is just a little snippet back to the kind of whole crypto miner concept of, like, here, it's a bit hard to see from a distance, but basically, the first 6 rows are a user trying over and over again to run a crypto miner. And then that same user comes back 3 days later, and then the same user comes back 5 days later, and tries exactly the same thing every time. And, like, it fails every time, but they keep going, which is kind of a good example of, like, if it's in the public, people are going to try strange things with it. And, like, what it actually comes back to is, like, mitigations and how much damage control we've done. Like, have we removed any, say, private data from the accessibility of that environment? Like, have we limited anything someone could get? And ultimately, is it harder to use our free resources than just to launch a box on Amazon? Because this is the kind of thing that's super easy now and pretty cheap. So back to serverless of like, would you ever actually do this? And hopefully the answer is no. Like, it's a fun use case to talk about. It's a fun thing to look at. But it's really rare that we want users to be able to run code in our environment. But the kind of cross things we know about this is actually, it's good to think about from a security point of view of like, if we get to a point where an application has an issue, like security issues aren't as rare as we'd like to think. So like understanding possible pivot vectors, understanding where things can go wrong and where users can go after an exploit is useful. So like having a thought of kind of how the serverless systems you're running behind the scenes actually work is really useful. And equally, building it back into dev life cycles, like thinking back to least privilege, thinking back to making sure systems only have the access they need. These are still all super kind of important in a serverless world as well as a server stateful world. As we look more at, say, serverless tech, there's loads of solutions out there. This is a mix between, say, serverless and cloud native. Like, as we get into Amazon Lambda, Google Functions, Azure Functions, these are worth thinking about, like, how you can use them to evolve your business. And, like, this is the crux of kind of what I've been talking about so far. The kind of key topic is, like, what DataCamp has done, aside from building a serverless platform, is actually they've used the concept of serverless technology, in this case, user-facing serverless technology, to build a part of their business. And this is what we need to be thinking about when it comes to Docker, serverless, anything new we're building, of like, how does this not only like make a dev workflow better and make someone's life easier, but also, can it change how we work as a business? It's like, can this do something our business wants to do? Or can we use one of these to leverage some new technology that we want to be in? It's not just a case of kind of, can we use Docker because we know we want our devs to be happier or build services a bit better, more reliably, but we can actually get kind of business value out of these things. Just to kind of narrow in on one of them specifically, Kubeless is a good example because actually serverless isn't always without a server, which is a really weird concept. So in Kubeless example, actually, you can run your own Kubernetes platform, which means you're running your own servers, and then you install a tool like Kubeless, and so you're going, so our devs can now deploy serverless code, but we still have to maintain servers. But actually, this is still a win overall, because it's not just the concept of getting rid of servers. It's not just the concept of reducing infrastructure overhead. It's not just the concept of like making things easier day to day. Serverless changes a lot of things for your dev lifecycle. It changes how you think about servers, or how you think about services. You have to think about, this is only me running for a second, maybe 2 seconds. Okay, I have to change where my state's stored. It might be re-executed from scratch. It might be re-executed from a cached, already running container. Okay, I need to really think about my dependencies, what I rely on, how they're working. These are a lot more of the key concepts of serverless, and these are where it actually drives a change in the industry. So these are the kind of key topics that actually are driven by serverless, and to some extent already being driven by Dockerization and containerization. Because these are the concept of breaking away from traditional monolithic, large, high dependency, high state services, and breaking it into smaller, reusable, easy to deploy components. Particularly in our use case, we're actually doing this in the case that a user comes to our site, we launch a container for that user, and then we kind of serve requests out of that. And this is a world like we've not previously been in, and it's something that's kind of, it's a really weird concept of like, if a user comes to your site, you're spinning up a set of infrastructure just to serve that user. But yeah, I mean, the underlying concept is much more about how can we use this technology to enable functions of the business, and actually kind of how can we change the way that our business works to use them. So I've actually flown through that. So yeah, that's all I wanted to say today. But if anyone has any questions, I'd be glad to hear them.